This video is being filmed for the Northwestern Chemistry 182 class on the subject of obtaining alum from aluminum foil and recrystallizing it from a solution. Within the first part of this lab, we will discuss the synthesis of alum from aluminum foil. The first step is to obtain 1 gram of aluminum foil, a 400 milliliter beaker, and 50 milliliters of 4M KOH. Within our lab group, our mass of foil was 1.0588 grams. The next thing you must do within this lab is pour the 50 milliliters of 4M KOH into the 400 milliliter beaker and place the aluminum foil into the solution. Pass the solution through a funnel with filter paper at the bottom to remove the insoluble solid impurities that are found within aluminum foil. This filtered solution must then be poured into a 250 milliliter beaker, along with placing a stir bar inside of it. This next step is important to be done slowly and gently due to the fact that H2SO4 is a strong acid. That being said, the next step is to add less than 25 milliliters of 9M-H2SO4 to the filtered solution, and then to wait for the aluminum hydroxide to precipitate out of the solution. It is important to wait until the reaction is complete in order to confirm that all of the aluminum hydroxide has precipitated out of the solution. At this point, you add the rest of your 9M-H2SO4 to the solution. It is important to do this step because the additional sulfuric acid neutralizes the basic precipitate and causes it to dissolve. In order to further the dissolving process, heat must be added. Begin gently warming the solution on the hot plate while stirring it with the stir bar mechanism. Place the 250 milliliter beaker with the dissolved alum into an ice bath in order to bring down the temperature of solution and allow for the now dissolved alum to crystallize. Part 2 of this lab experiment is washing the alum. Pour the alum solution into a vacuum filtration system. Then you must turn off the vacuum while the alum is in the funnel in order for the alum crystals to actually be cleaned instead of having the cleaning solution entirely suck down the funnel. Rinse the alum directly in the Beekner funnel with 5 milliliters of 50-50 ethanol water mixture. Gently stir the contents with a glass stirring rod and proceed to turn the vacuum back on to remove the rinse. This process should be repeated 2 more times in order to ensure that the alum has been entirely cleaned. After the third completion, continue to pull a vacuum on the solid until it is completely dry. Part 3 of this lab involves recrystallizing the alum crystals inside a 20 milliliter vial. The first thing you must do is obtain this 20 milliliter vial and label it with your initials, the date, and your lab time. Then you must measure out approximately 5.64 grams of alum to saturate and pour into a beaker filled with water. Our lab group massed out approximately 5.7066 grams from an amount of 7.1810 grams of alum produced during parts 1 and 2. Then the solution must be heated in order to supersaturate it. Allow this solution to cool back down to room temperature, and then filter out any remaining solid by gravity filtration in a 5.5 centimeter filter paper directly into one vial. After this step has been completed, it must be capped with a Kim's wipe and a rubber band in order to ensure that the solution slowly evaporates and does not do so too quickly or does not evaporate at all. This is important because without this slow evaporation, crystals would not be able to form at the bottom of your vial. I will proceed to describe to you the crystal growth description of my crystal within my own 20 milliliter vial. There is a cluster of white particles that appear to be beginning to form at the bottom of the vial. They appear to be forming one large crystal that can be best described as a geometric variation of a triangle. The crystal is not densely packed, but appears to be as though it is a free-floating cloud at the bottom of this 20 milliliter vial. I concluded the beginning of the crystal formation looks the way it does because it needs more of the solution to evaporate so a more proper crystal can form. In my theory, it is also free-floating because it has nothing to grab onto within the vial to anchor it into one place. A side note that must be added to this video is that post-lab, my vial did not contain a full 20 milliliters of solution. due to a complication with the gravity filtration system in which it was fairly possible to filter 20 milliliters solution from the funnel. It is also an important add-on to say that when this picture was taken for this video, my vial had been knocked over and the cluster cloud of what proceeded to look like a triangle forming of crystal at the bottom of the vial proceeded to no longer be present. I feel this is an important add-on so that my testimony is not seen as false representation of what is happening within my vial. Thank you. In order to grow crystals of table salt, or NaCl, I would follow the following procedure. I would supersaturate a solution of salt water, that is, of table salt, NaCl, and water, and then I would proceed to soak a piece of cardboard with said supersaturated solution. Then I would proceed to warm this supersaturated solution of piece of cardboard and dry it out. One would find that numerous small salt crystals will form on the surface of the cardboard after a few hours. Another way to grow crystals, according to sciencenotes.org, is to use a seed crystal. In order to do this, you must pour a small amount of saturated salt solution onto a watch glass, and as the liquid evaporates, crystals will start to form. Use one of these crystals from this dish, and then pour the supersaturated salt solution into a clean container. Allow for the solution to cool, then hang the seed crystal on the solution from a string attached to a pencil placed across the top of the container. This solution needs to be saturated and cooled so that it won't dissolve your seed crystal. Then, once the solution starts to evaporate, crystals will start to form on your string.